welcome back, Matt.
Hey, glad to be here.
How have you been?
Yeah, pretty good.
Yeah, all well out in the East Coast?
Yeah, life's been pretty nice. Had a decent summer. We just got a whole bunch of rain, like 4 inches. That was pretty intense, but
No flooding, though, right?
yeah, no flooding. I'm pretty safe where I am here. Some places aren't around this neck of the woods in Massachusetts, but I'm pretty close to the water, and the water flows around me pretty well.
Nice.
Can get right out to the ocean, so to speak.
There you go. Well, what are we doing today, my friend? I'm looking forward to a safari.
All right, yeah. So today, wanted to show off a couple of my new microscope things, and we were going to look at specifically a horizontal soil build that's indoor. It's in a 6x4 bed. Actually, if we want to just get right into that, I can. If Ken wants to bring up a little video that I have here, and we can get into that. So yeah, this was at about a month ago. This was June 1st. And this is all inspired by, Leighton's horizontal soil build and everything like that. And here is it just a couple days ago, June 29th. And this is actually the 8th run in this bed. So I've had 7 successful runs, and with very little amendments. I mainly just put a little bit of Build the Soil Craft blend, slow release nutrients on the top. And I had to add a bunch of oyster shell because we'll look at my soil test from this bed right before I started this run. And we can go over that a little bit, which I think will be interesting. And then we could look at some microscopy of this soil. Oh, so this is Ruby, my crested eye gecko. Here, we got a better shot of him coming up there. So I decided to throw him in the bed. And he does a good job of eating the isopods and, just a little addition to the ecosystem.
Oh, that's
the
cool.
whole food web and whatnot.
Now, do you let him escape and then catch him, or is he always in his cage?
Yeah. There's Nymeria. No, he pretty much stays in that little area, but he has escaped quite a bit, and I find him some random spot around the room and put him back in his cage.
Nice.
But yep, I got some turmeric growing over here in a little pot. That's actually been quite productive. And this is the other part I wanted to show here. Eventually we'll pan back down to it, but I put these 2 tubes going right over the clay horizon. Okay. So I can water right into those tubes to do a little bit of bottom watering.
Nice.
And that makes it much easier to keep the lower parts of the soil damp. Otherwise, I find it tough with a bed this size to keep water consistency throughout the bed indoors.
So let me ask you this: do you have a pan underneath it, or no? You're just relying on it itself.
It's rolling. It's on a plastic sheet with like 30 coaster wheels on it, so I could actually roll it around.
Oh, nice.
And there's holes drilled in the bottom, so if I ever overwater, it could just drain right out the bottom.
Okay, so you're not relying on the sand layer as a reservoir or an aquifer.
No, yeah, it can drain out the bottom, but I find it holds it pretty good because I put quite a bit of salt and clay in there.
Yeah, sand is amazing as far as moisture storage. People don't realize it. It can drain, but it also can hold moisture.
Yeah. So here's my soil test that I did. And this is a Haney soil test from Regen Labs, and going through for the pretty much all the levels that I went through. I was pretty happy with organic, the inorganic and nitrogen levels were all pretty decent. Total phosphorus and everything like that. Like look at the total P is like 85 parts per million. Like,
can you zoom in, because it's really hard to see? Like maybe zoom in on half of it.
Yeah, I can. How can I? So if I just go,
there you go.
Whoa. So now we can kind of, So now I can read a little bit better.
Yep.
now going across with the NO3's only 10.4, but
pH
not
6.5,
lacking any.
nice. Buffering,
Yeah.
6.7, soluble 3.5,
So
express lime, soil organic matter 34. That's beautiful.
yeah, the amount of
Up to 9
you know,
total at 28. Sweet. Extracts. Nice. Soil health. H2 extract. Carbon. Wow, that's looking good, dude. See the N ratios
Yeah.
not bad at all. Fucking almost 10.
yeah. As
Cover
far as
crops.
coming down to the
This in grass or legumes in grass.
legumes and grass was the recommended cover crops.
Okay.
But as far as looking at my my calcium and my cation balance, the main thing I found is my magnesium being 300 and calcium being 700. I'm way off that 7-to-1. So pretty much the one thing that I did as far as the soil sample, the first thing that I saw was let's add a bunch of oyster shell.
Oh, that's good. I mean, it's really 7-to-2. The one is the potassium part.
Yeah,
So,
because potassium and that's part of the cations too, the potassium and the sodium. So considering they're decently,
yeah,
high for the amount
and
of
you've
potassium
got
and
decent
sodium.
magnesium, decent iron. Copper's a little low. You might want to try to get a copper sulfate. Yeah, it has a lot to do with internal plant processes, but just adding a little bit of copper can really strengthen the plant itself.
Yeah, I like carbon to nitrogen ratio. It's almost a 10. pH perfect 6.5. Haven't done anything to change or modify that. Just let the biology do it. And yeah.
No, I think you're in a good, happy place.
Mm-hmm.
Oh, there's the seed head ratio. Yeah, that's nice.
Now I'm getting ready. Here's the soil before I after it settled. If you can see, look at that big head of organic matter floating on the top.
And lift it up a little. Yeah, that's nice. That's a great
and clear as can be after just settling for 5-10 minutes or so. So those plants are so healthy from the biology because there's not much of that water soluble nutrients in there that would turn the water all brown and not settle out.
Yep. No, it's not a good source of humic acid because the humic acid is being consumed by the biology. That's what actually makes clean water. Is the biology grabs that humic right out of suspension and puts it in their body. I mean, there's a really cool video at Rodale where they show 4 different soil samples or types in a plastic bottle, and they pour 10 mils of water into each one. And the one that was grown is pure organic matter and organic and regenerative farm. They didn't use the word regenerative back then. The water comes out crystal clear, and there's very little of it. And then when you go into the conventional ag system, the entire 10 mils comes through and it's cloudy. So the biology has a direct effect on cleaning water and stripping it of everything from metals to carbon to humic acid.
All right. So now I'm preparing the slide.
And this is soil sample from the garden bed?
Yep, from that bed that we just looked at, for that indoor bed. Throw this on here. All right. Click on the microscope. And let me go over to microscope view. And can get dialed in here. So yeah, turn down the light a little bit. There we go. Yeah, so it's surprisingly clear of a slide from what I saw. Just dropping everything down here because everything's all held up in all the organic matter.
Yep.
Very little.
What magnification are we at?
We are at 100x right now.
Nice.
Yeah. So where am I on the slide? I'm right there. All right. So yeah, it's a really nice slide. Oh, there's some sort of, it's either a cyst or amoeba right there.
Yep,
And we can do, geeked out a bit on the microscope, and now we could do zooms.
Nice. So if it's double walled, it's an amoeba. So that looks like an
amoeba. And
you know what I saw the other day for the first time in my life was a thing that looked like a nematode, but it more resembled a worm or caterpillar. So it didn't have a tail and a head. They looked identical on each end, and it crawled through the solution in a straight line, unlike a nematode. And it wiggled a little bit, but not much. And I was like, I tried to get a picture of it, and I couldn't. My damn camera phone. The phone on this new camera has 3 lenses, so it doesn't focus through the old holder that I used with my microscope. So I'm gonna have to figure out something.
So one cool thing that I invented, or well, not invented, but came up with, is now I have a 1 ruler.
Nice.
That I could just drag along the screen and measure stuff. So here, I'll actually show you that. So that was this. Yeah. So I bought this little slide, and you see that little tiny thing in between the circle. That's the measurement. So now now I took a picture of it, traced it in Inkscape, which is like same as Illustrator for Adobe, but Inkscape is a free open source software. And then I could zoom in and then measure the perfect distance to create 10 more lines between every other line and get down actually to 100th of a millimeter and 1
Wow, very cool.
So now whenever I want, I could just bring this up on the screen and measure stuff.
Very cool.
So I was actually looking at this these strands of fungi coming in and out of the root, and we got to go over to epifluorescence for this. See what's actually going on there. Oh, got to turn light way down.
So that's a root here right there?
Yeah, that looks like a piece of fungi along the root, but it's a root hair right in the middle. So let's see if I can get this fully dialed in here. If I turn, that's the backlight all the way off. We're pretty bright. Let me just adjust my camera settings a little bit here. Oh yeah, I know what I gotta do. I just gotta close that down. Now, we'll bring that up and get focused. Yeah, so now we're actually looking at the root.
Looks like you have an infection site. Up at
right there when we saw that, and you can kind of see it wrapping around. We actually even zoom in a little bit closer there, right on 4x.
So the interesting new latest findings on mycorrhizae was they have a microscope that they can film in situ for up to 50 hours, which was incredibly powerful. I mean, we've never been able to do anything like that.
Wow.
And they could record it and film it. And so what they learned was some of these mycorrhizae would only be around for a couple hours, and then they would basically die off, and they'd leave come out of the infection site, and the infection site would heal, while others would continue to trade and work with other plants around them for up to we don't know. It was beyond 50 years. So very, very cool new understanding that mycorrhizae has different levels of survival rates, and we don't know whether that's just an evolutionary thing or maybe it's a shift in the biological community. But it'll be the next thing to start focusing on to understand it. Because before this, we never knew that some of these species died really quickly, and others lasted for hours, days.
Yeah. I was just seeing I just saw a new study that they did on mycorrhizal or just endophytic fungi, and their calculations for worldwide is, and if you stretched it out, it comes to be like solar distances, and they're estimating 10 trillion solar distances, a quarter of the size of the Milky Way if you stretched out all the endophytic fungi into one single strand. I thought that was.
And I bet you the mycorrhizae, the VAM, is even further.
Yeah. It's hard to even
fathom.
Like, I thought it would wrap the world maybe, 10 trillion times, but not
trillions of light years out.
Yeah. Not a quarter of the galaxy. Like, to wrap your head around the circumference of the Earth and then the distance of from us to the sun.
Yeah. What do we have there? A little paramecium?
Yeah. Little silly rolling around in there. One of the little spirally guys.
If you zoom in, I think it's a paramecium.
Yeah. Very, very flat and twisted around. It probably has that little bend in them. Small one. Yeah. Still at 100x. Oh, there's a flagellate moving around down there. Or maybe not. It's not bumbling as much.
But no, it might have been a fast
mover. Yeah, I'm still at 100x, but yeah, we could get a little scale of him there. He's about 6 to 8 UM long.
Was that an amoeba off to the right? Or is that
a right? No, it looks a little bit like crystal. Something else fast moving just went up this way. But I'm just going to continue this scan around for right now. Yep. Other little guy tumbling around in there. Oh, fast mover up there.
Yeah, that's definitely a ciliate.
Yeah.
So are you watering with pond water?
I have a rainwater collection.
Okay.
So I mostly water with that. It just falls off, collects right into my gutter.
And it goes into
I got like a 200-gallon tank right off the side of my roof, and that's mostly what I water with. Nice. The edge of the slide.
That's why you're getting that diversity.
Mm-hmm.
It's probably filtering through leaves and stuff.
Yeah, I probably haven't cleaned the gutters in a while, so
Which, dude, like I did this experiment.
Probably a lot of leaves up there.
Yeah,
oak leaves. There's a huge oak tree over that side of the house.
So I did an experiment years ago where I collected leaves out of a gutter that were like less than a year old and some that were like 5 years old. Like, it almost turned to complete muck. And the level of diversity in that stuff was incredible. Oh, there's a little amoeba, I think, up top. So to have it filtering through those leaves is a good thing. Leave the leaves as long as it doesn't flood over.
Little amoeba, we'll probably find another small one right there in the middle. Scan around a little bit more. Let's go back out to stock 100x. See what else we can find. Kicking around in there. But yeah, saw something else fast moving on the side.
Now,
little piece of fungi.
Was this sample from the organic matter? So on the top?
I did 3 inches down.
Okay.
And I tried to do an even combination of that 3 inches. So I took a little bit from the top, a little bit from the midsection, and a little bit from the bottom.
Gotcha.
Yeah.
There's another fungal ivy there on the right.
I think it's a root, and then we got fungi hanging off of it over here to the side.
Oh, what's that?
I think this is a very clear, maybe a young, because you got the little club up at the top.
Yeah, but he's got a tapered end. So it almost looks like a nematode.
It does look like it has kind of a double cell wall there.
Huh. Yeah, you might have popped
very long.
Yeah, you see how his head's popped?
Mm-hmm. Yeah.
We killed him. But there is one just above it that looks like a baby nematode, but it's not moving.
Yeah. That was something right above it. But we got some more organic matter. Go back out a little bit farther, see what else we could find. But it's weird how the soil is, how it's advanced. It's a lot of big chunks. It's hard to get a busy slide. It's all very clear. Well, there's a nice piece of fungal hyphae. Yeah, and it's like a lot of the fungal hyphae that I was seeing and counting before was probably mostly just the saprophytic fungi.
Yep.
And that will like increase depending on what mulch I use on the surface, and then kind of decrease when all that food goes around. But then I'll see very little fungi in an actual soil sample, and then I'll look at a piece of a root and see all sorts of, with the epifluorescence, all sorts of endophytic fungi still in the roots. So it's some little protozoa.
What is that right in the
moving that around? No.
Is that a cyst or?
No, I think it's just somebody moving around and whatever that is.
Oh, there. Now I can see.
Yeah. Now you could. Yeah. Just another one of those little, whatever type of protozoa that is.
I've been seeing a lot of interesting facultative anaerobes. I actually saw one that I'd never seen before. Very weird shape. It looked like almost like a recliner. And the way it would move is it would fold the back part where you'd sit down toward the seat, and that would propel it. Really bizarre.
See if we can get a good look at whatever this one is. Hiding over there. He was just spinning around on a piece of something. Yeah, not a little ciliate.
It's actually acting more like a facultative.
Yeah.
Ciliate's just zoom. This guy's actually mining stuff off the circles.
Probably one of those ones that has like kind of like 3 cilia sticking out of his mouth.
Yeah. You know the stock ciliates, right? The street sweepers.
Yeah.
And the rotifers, they're really cool to watch. I mean, they just tear shit up.
More fungi. Where are we on the slide? Right here. Still doing our, just kind of mowing the lawn, as they say, for the 100x sweep. Yeah. Other little, that one's definitely bumbling around like a flagellate. Let's see. Anything else cool? Go over a little bit, back up.
So you're looking at the screen.
Another one.
How big is your screen?
So I have a 40-inch right here, and then I have a 30-inch right here, or 42-inch and a 30-inch.
Nice. That's why you're able to see shit that I can't see.
Yeah. So a lot of times I'm like, oh, look at that. And I'm like, wait, I got to zoom in a lot more for everybody else to see what's going on.
There's another blown up nematode.
Yeah. Another blown up looking nematode. Zoom in a little bit on him.
Yeah, you see how that head just exploded? And if you look, there's still a little bit of food in his stomach.
Mm-hmm.
So that would definitely qualify as a nematode.
Hmm.
You know what I've learned to do, or I've been doing for years, is I always take 2 slides, 2 drops, and 2 cover slips of the same. Oh, there we go. That might be a live one.
Another one. Oh, he's dead.
And I do nematode scans on both, because you don't know how many times I've had no nematodes on one slide and a ton on the other.
Yeah, exactly.
I've had this conversation with Andy a number of times. It's like, hey, I know this is outside of protocol, but you know, I'm fortunately qualitative, not quantitative, so I don't have to follow strict rules. But I don't understand why that happens. She goes, well, it's mixing. I go, well, obviously it's mixing. And, you know, we were taught to do, you know, Elaine's, you know, 30 shakes. And then this other gentleman that I worked with, Michael, he would actually do the shakes, then take the cap off and squish the water in and out with a pipette and stir everything up.
Yeah, that's what I kind of did with this one a little bit.
Yeah. So you get a broader overview of what's going on. You're not like, if you just extract the liquid off the top, you'll see one community. And if you go all the way down to the bottom and you extract the silt and clay and sand, or from the silt, sand, and clay, it's a different community.
Yeah. I feel like the nematodes like to swim down too. So if you draw, like if you let it sit for like even 5 seconds and draw from the bottom, I tend to find more nematodes.
Agreed. And from the top,
drawing from the top.
Yeah, it's a real quandary. Like, you know, we're only getting 1 drop of potentially, you know, acres of soil. And now we're required to kind of direct our client, like, okay, this is what you should do based on this tiny, tiny snapshot of the overall picture. And, you know, and I think Andy has it right. Even qualitative, it's still quantitative. It's still quantitative. It's just still a guess, unless you do thousands of views. And that's kind of where I'm hoping AI steps in and gives us that tools for us that we can just, like you're doing now, run it through a computer and have, you know, the agents pick out what we're missing or, you know, potentially missing when we're doing it.
We're going to switch over to 400X so we can take a look at some bacteria and whatnot in there.
Is that a little diatom?
Yeah, I think so.
It looks like it's got a nuclei.
See if we focus a bit.
Can you see green in it?
Yeah, there's definitely a bit of green.
All right, so that's a solar panel. That's definitely a diatom.
Yeah.
Or I should say chlorophyll.
And we could see our little measuring to see how big it is.
Now, does that measurement stick go down with the different scales?
Yeah. So what I'm at, you know, I just maximize it because I'm 1-to-1. Like I have a 4K camera. I stream it half that at, 1080p.
Yep.
So then once I did all the math, and now I can just, 1x or 2x or 4x the ruler that I made. And then I tested it out with the one that I bought to make sure it was on scale. And it, 100% matched up every time.
Very, very cool. Kind of figured we'd see more bacteria in this. I mean, those plants are going ballistic.
Yeah. But it's almost like.
So those were only 1 month old, right?
Yeah, well, I put them in that bed a little over a month ago, but they were starting for probably a month before in the the starter tent before I transplanted them into the big bed.
Are you in flower mode right now?
Yeah, So now I'm in flower mode because they're gonna overgrow the room. I'm gonna have to do either some super cropping or quite a bit of trellising.
Yeah. Is it typically a very stretchy cultivar?
No, right now, I'm doing a new cultivar. I do have one of them's Grim Glue, which tends to be pretty stretchy. That's probably the biggest one. But for the first time, I'm doing Joker's Marmalade. I'm kind of interested to see how that turns out. But also very fast growing, but not stretchy. Seems to be a pretty sturdy plant.
That was the one in the back, right?
Yeah, there was one on the right sides, and like the first one when we got in that I grabbed a hold of was the Grim Glue from Brothers Grimm. And then where did I get who was the Joker's Marmalade from? But yeah, now we're seeing a whole bunch of more fragilates down here at 100x. Cruising around. And then big guy just came up. Yeah, so those are the big protozoa that we were seeing before, but they're out of focus now since we're in that 400x. No, there's a little amoeba.
Where I can't.
Yeah, testate amoeba. Yeah, I could zoom in on.
Oh, there it is. Got it. Center screen.
Yeah, 2x.
Nice healthy one. Open mouth.
Yeah, big open mouth. He's got the Pac-Man ghost thing going on. Yeah, we can even go in at 400x. If I could just, there we go. And then maybe a little bit more focus. Yeah, tough to focus.
Yeah, no, it is.
This deep in.
That magnification is tricky.
Yeah, because now I'm at 4x, 400x. So we'll go back out to regular 400x.
Slide's starting to dry out on it.
Is that just a slide drying?
Yeah.
Weird that's moving. I thought it might be somebody carrying that on.
I was going to say, it didn't have to be a monster flagellate dragged out.
Yeah, it would have to be a big old cilia or something to be dragging that around. But yeah, when you get in close, it's amazing how much small, fast life is in this bed. It's later years. Like at first, I saw more saprophytic fungi and stuff like that, and very little flagellates. And now it's sort of evolved to the point where it's a whole lot of these fast-moving little tiny flagellates, and not much saprophytes. But when I look at a root, I got tons of fungi in the root.
So, still, to answer your question,
little pieces.
Nematodes swim down when you stop shaking the bile. So the kind of concept is understanding that nematodes are like a water balloon. So they're very easy to move in the water column up or down. And generally, when you stop shaking, they like to swim down into the organic matter. So that's why that whole Elaine's shake method was designed. And then some people do the double squirt, which is when you put the pipette in there and squish it twice or 3 times to stir the whole column up. And that's to help pull out the nematodes that are digging down into organic matter. That looks like a sap.
Yeah. Oh, a little piece of fungi. Yeah, I'm surprised I haven't found a couple more diatoms. Just kind of randomly skimming around. Yeah, but it's like with the soil and being, how clumpy is thick it is. It's really hard to make an interesting slide.
Yeah, it's all good.
But we got a couple more roots here.
Yeah, if you want to kick it back to epiphorescent, we can check them out.
Yeah.
So I had an interesting project out here in Malibu. It's right on the ocean. And wow. Underneath the coral trees, I saw tons of diatoms because they come in on the wind and the ocean spray. And the interesting thing was they were a lot different shapes than we see typically like in fish brew or on the East Coast. I just found that very interesting.
It's hard to get a good focus on things with.
Do you use any mycorrhizae inoculant products?
Yeah, I'm currently using the Mycogenesis from AEA.
Okay.
Advancing Eco Agriculture. And I also use some.
There's a nice infection site.
Yeah. Should have grabbed a couple of bigger roots to throw on the side.
We got plenty of time.
That's a little tiny root.
You ever heard of border cells on the roots tips?
Yeah, a little tiny. And then a couple of times I've always wanted to see get a fresh root tip and then put some water in, then actually see bacteria, swimming in and out of there. Like if I could get in this close to this is a good example about how close I can get to a root tip. But it'd be interesting to see them actually.
I don't think you can see the endophytes. I think that they're so small that, and they're probably very clear because they lost their outer shell, and they don't form a new shell till they get outside. But the other thing I was talking about are border cells. So border cells look like the little panels on the space shuttle. The ones that broke off and caused problems. Well, border cells actually shoot off when the root tip hits an anaerobic zone. The first thing it does is it sheds all its border cells and pulls back, and the border cells go out and act like a barrier between the anaerobes and the actual root tip, because that's the most sensitive part of the plant is that root tip. It's fresh, brand new, and susceptible to all kinds of bad things. Ooh, that's a green little cool green.
Yeah, whatever that is glowing very bright.
So anyway, the border shells act as the first line of defense when a root runs into something that it doesn't want to be in. And there's some videos on it, some different science channels, but it literally looks like an explosion. Like it just blows all these little shields off the tip to try to protect itself, and then recoils on itself. Very interesting plant reaction. Ooh, another one. That might actually be a diatom.
Of course, it's fuzzed out just a little bit by what's next to it. Yeah, that's about the best focus I can get on it.
Have you ever seen the bioluminescent biology in your ocean at night?
Oh yeah, it's wild here in the river, especially when the water gets warm.
Yep.
There's times that I've seen some video of when it glows blue, but here it glows green. So you'll jump in and it'll just be whole water. If you do a cannonball, will just blow up with a huge ball of green.
That's cool.
And then for the back of the boat, like the waves are almost just too green, like streak coming out.
Yeah, I was very blessed back in, God, it must have been in the 90s. No, it would have been 2000, early 2012. I got to go down to an island called Vieques, which is off the southern coast of Puerto Rico. And they had the most active bio bay pretty much on the planet. And they would take you out in pontoon boats, you could go out in kayaks. And they actually at that point let you swim. And you looked like an angel. Like my took pictures of it. You'd swim and you'd see these like, angel wings coming off of you. It was really freaking cool. Then, as always, humans screwed it up and they banned people from swimming anymore. And they have people out there watching the boats that do take people out to make sure that nobody jumps off. And they fine the heck out of the boat. Yeah, bow tie life. You can see videos on that. Just search Vieques bioluminescent bay Taurus, and you'll probably see a ton of videos on YouTube. Now, the crazy part is what they didn't realize until this accident happened was that's a breeding ground for some of the most dangerous sharks on the planet. It's right next to, it's within a mile of the giant trench off the southern part of Vieques. Water drops thousands of feet out there. So these big sharks, tiger sharks, bull sharks, they come in there and they leave their egg casings behind and then swim back out to the deep. And so this one particular case, there was a woman who was bleeding and she got attacked by one of the females that were laying her eggs. And unfortunately, she died on the way to the hospital. And that's when they shut the whole thing down for a couple of years.
Yeah, but it is wild. Around here, there'll be, the phosphorescent algae will be peak for like 1 or 2 days. And then after that, they'll still be there, but it won't be like the whole water is glowing. Like you move around, you'll see a couple, but then for like, it's really only like 3-4 days a year where they're just everywhere.
I think they call them dinoflagellates. And that's actually their defense mechanism. Here we go to zipper.
Yeah. But yeah, one thing that I'm noticing about this bed is that there's no shortage of fast moving little tiny guys.
What is your moisture level at?
Everything's wiggling around. I have an eco width, and usually I water up to about like 60, 70 and let it get down to about 30.
Gotcha.
And then water again. And I think right now when I took it, I think it was reading 40.
There's a nice flageolet.
Yeah.
Meandering his way through the slide.
A little. Yeah, this guy's tiny. Like, on the scale. Like what?
Yep.
3 UM or so?
Yeah, maybe it's
I'm at 2x 400 right now.
Might only be 2, right?
So it's kind of like looking at something at 800x. Is how far I'm zoomed in right now. That's why it's tough to get anything really, really well in focus. Because we're pretty.
Have you ever seen a motile bacteria plume? So it's like 1,000 tiny little bacterias all in one area. It appears my intuition was that it appears like they're attacking something, but they're all wobbling very fast, and this whole clump is right on top of something.
Mm-hmm. Yeah, usually I'll find them like in find a whole bunch moving around like that. Like sometimes just in kind of like a cove or of an aggregate. That one's pretty round, but if you find like a little pocket in an aggregate, there'll be a whole bunch. Yeah. Tiny piece of fungi. And a little round.
That might be a naked. That might be a naked amoeba off to your left. Is it moving?
Mm-hmm. Left. Over this way?
Yeah.
No, I think it's just a thin piece of.
It's an aggregate.
Yeah, thin piece of something.
They're really cool to watch them use that 1 foot to push them through.
Yeah.
The solution. 1 foot at a time, I should say.
Small fungi. Yeah, it's wild when you're at 2x 400 how much you can start seeing wiggling around in there. And you go in closer, and yep, you start seeing all these little tiny blurry streaks flying around. So there's even more down there that we don't usually see. Couldn't focus on that one.
Yeah, with that level of focus, you can actually start kind of counting colonies or communities.
Yeah, we're way in there. Kind of like I can't wait until this might be a little. I can't quite tell, but that's a little cluster of bacteria of sorts.
Yep.
On whatever small little piece that is.
Those are the modal bacteria.
Yeah. But yeah. Definitely a lot of motion when you get in this deep. A lot of stuff that you don't see at regular 400 or whatnot. And then when you go to 1000x, remember you're now shrinking your focal plane down to like a super thin shred.
That's
so
like,
a lot of these fast moving things you want to be able to see. Well, we're technically have even though we're at 400x and just digitally zooming, and it's not.
Yeah, you don't have to have the oil immersion lens.
Yeah, we don't have to have the oil immersion, but we're still seeing a much thicker slice of the plane.
Yep.
Because of the focus. So it really gives you a cool idea of just how much is going on.
You got to be like
down there.
1200x.
Yeah, pretty much. Now we'll go back to 2x. So now, being my camera being 4K and us being in 1080p right now it's pretty much 1-to-1 pixel at 2x. So like 800x with a 400x objective would be the equivalent size of the image that you're looking at, depending on your screen. But it's pretty cool that we can get. I'm kind of excited for when 8K cameras come out, because then I can have a 1080p image with a 400x objective all the way at 4x. So then we're gonna have an even better resolution.
You're talking about going subatomic particles on me.
Yeah. Not sure if we could do that with light.
I'm teasing, but you could definitely probably see oreganellos in the bacteria themselves.
But you could definitely do. I like what digital microscopy brings. I mean, digital microscopy brings, because you can go a little bit farther and see a little bit more. But there's still the limitations of light.
Yeah. Which,
no matter, even if you had a 12K camera, you're not going to really improve on that. I think I was already over this way. Yeah. Oh, there's some cool colors. Probably is it glowing super bright? No. Would be glowing super super bright if that was microplastic, so it's not that. Interesting little strand. Yeah.
You want to try another sample before we get to the hour and a half mark?
Yeah, I could go snag. Wow, a lot of stuff. We want to try to do go grab our I can run downstairs and grab a root real quick.
Yeah.
Probably toss that on there. If you got a second. If you could,
yeah, absolutely. We got time.
Hold people over for just a moment. It'll only take me a second. Oh, there's a nice little club of a fungi. Oh, we'll leave it there. Yeah. With everybody. Oh. All right, I'll be right back.
All right, sounds good. Ken, you want to hop on?
I'm here.
There he is.
I'm just blown away that, you can, because of his camera, because of all the things that he's got set up, he can go so deep and look so deep. It's like, I'm amazed.
Yeah, it's he's done a wonderful job, like bringing these different technologies together and getting them to provide that level of insight. It's very impressive.
Yeah, and that ruler,
right?
How many people would do that, Leighton?
Nobody I know. I mean, that's why they put them on the microscope slides or on the slide, not the cover slip. With Elaine's special chart there. And so, but this one moves around, which is like a whole nother level.
Yeah. Well, I think that's something he could patent. And, I think you'd love to see that one too.
Yeah, I'd have to get a microscope at his level, which is pretty darn expensive.
Yeah. Yeah.
And plus, I only do qualitative. I'm not doing quantitative. And it's only for me. Like if I need qualitative, I'll send it off to, or quantitative, I'll send it off to Andy, have her run the full counts.
Yeah.
But I'm more looking, just kind of get an overview of what's going on. That's another reason why I do 2 cover slips per slide. So I'm getting a better average of what's going on. But dude, when they release AI that can like scan the entire slide and come back and tell you, all right, this is what we found, that's going to be next level. I mean, talk about a diagnostic tool.
Oh. Well, and I'm sure it'll be able to quickly flash through all of the levels, in a microsecond from, 2x to 4x to 8x, etc. And then you'll be able to pull it up on your monitor and you'll be able to see it and go, wow.
Yep. And that's the other thing that people don't understand is that between the cover slip, the bottom of the cover slip and the top of the slide should be considered like a 4-story building. So at the bottom, you have the basement. At the top, you have the attic. But there's different organisms on different levels that generally hang out on those floors. So that's why when you ever see like Elaine doing it, she's constantly doing this with the fine focus.
Yeah.
But AI would do that automatically. And you imagine coupling that with the agent Craig has created with all the different testing results. Because that's not something we can do now. We can feed in Andy's report, but it's not going to, it's only a grainy at best overview. Whereas if you could do the whole slide and feed that in, oh my God.
Yeah.
Really give you some insights.
Well, I think we're getting so close to being able to see what we've never seen before. It's like Star Trek, right? Go where no man has ever gone before.
Right.
Okay, well, I'll jump back off and you guys can continue on.
See if I can get this dialed in here. Turn off the backlight completely. Do a little bit of focus. And there we are. I almost need to turn down the brightness even a little bit more. Yeah. So let's go down to, there we go. Yeah, so now we're looking at a cannabis root with epifluorescence.
Look at all those infection sites. Now, those little tiny dots, those may be endophytic fungi that live inside the plant.
Yeah, right now we're at 100x magnification. And I'm actually at 100x times 2. So there's 100.
It looked like there was a actual fragment coming out of that clump of organic matter right there at the start.
Yeah, right in the middle. Just a couple of bright spots. Just scan around, see if we can find some really bright spots. Focus in. No, let's.
Oh, there you go. What's that?
Yeah, we're moving up to. Oh, that's got to be some.
There you go. Wow.
Well, that might actually be a piece of microplastic right there. Unfortunately, the way that it looks. Thought it might be some Thought it might be algae, but now it's looking like a piece of.
So the epifluorescence highlights microplastics. Have you seen that before?
Makes it either glow bright red or bright green most of the time, or bright orange.
Did not know.
So I think that is actually glowing because it's microplastic, because it doesn't look like algae would glow bright red like that. And it's interesting when you hit them with the epifluorescent light, it almost looks like their redness will kind of like burst and they'll like stop, or I don't know, like whatever sort of thing they got going on as far as their photosynthesis does in algae and whatnot. It'll go from red to So now here we got a branch of the root. So usually when we see these branches, and this is the newer part. Oh yeah, and you can definitely see right here
that little orange dot.
Yeah, or just fungi growing in and all around the root. See a little piece of fungi?
Yep.
And that's definitely in there. If we go to 4x, see if I get focused on it in 4x. Yep.
Very cool. Now you can actually see all of the vascular veins inside of that plant.
Yep.
That is badass, dude.
And then, and those little, that's got to be fungi. It's a little too small to be root hairs sticking off right there. As we work our way up the tip, we'll probably get brighter and brighter as we get to this little end tip. It's weird. Occasionally I'll see things and see how it's contracting with the light.
Yep.
The root's act,
it's reacting.
Just alive. It's reacting, and actually the root is actually moving. A little bit that's focus, but when we saw it before, it was not focus. It's usually when you first hit it. Yeah, like right there. I'm not touching the focus. It's sucking in from the bottom. It's pretty wild.
It doesn't like you. It's mad.
Yeah. It's like, hey, I used to be in the soil.
Yeah,
I was in the soil like a minute ago, and now I'm getting this bright light.
We used to laugh about the fact that how often have you seen like a flagellate? When you catch him, he scoots under a piece of organic matter and doesn't come back out. We laughed about the fact that like when that little flagellate looks up, all he sees is a giant eyeball looking down on him, and he's like, "Whoa, what is that? I'm out of here."
I guess that's the end of the route. Oh, we got another little. Here's a route here. What's right up there at the tip? Yeah, a couple of times right here at the tip, I've seen some motion.
Yeah, some interesting stuff.
And some things going on there, but it's tough to catch. Usually you got to put water on there because this is just a dry root sitting on the, or well, not dry because it's just pulled out of the soil, but
it's not in solution.
Yeah, it's not in solution, so you're not going to see bacteria.
Is that another piece of that microplastic, or is that something else?
I don't know. It's kind of, yeah, very wrapped around the root. And usually when I find micros, it's not long strands. It's usually just little threads.
It's actually got a branch on it too.
Yeah, that's a little branch sticking off of that. Doesn't look like a tear or a piece of. So I think that's something with like chlorophyll in it. Maybe a little algae strand or something. Yeah, and something glowing bright red right at the.
Yeah, it's got to be alive.
Right at the tip there. Yeah. Other than that, let's follow. Oh, and here's the very end of the route. Oh, what's that? That looks interesting. Zoom in on that a little bit. Oh, no, I think that's just a fragmented piece of mineral up there. I thought that was a big clump of, endophytic fungi for a sec, but no, right there it just looks like looks like one of those weird pieces of mineral, clear mineral, stuck to the end of the root. Just a little tiny piece of clay. Look at whatever this orange thing is growing over here.
Seems to be just growing on the surface. Maybe it's a yeast.
Yeah. Could just be a bit of mineral stuck to there.
Does mineral often light up?
Maybe a calcium. Certain things do. Calcium tends to be orange, but not everything that you see is orange is calcium, from what I know.
So you're really getting into like a whole nother level of microscopy at this point, when you can actually detect, mineral and endophytes, mycorrhizae. I mean, did you study, read up, or take a course on it to get it?
Yeah, well, I took Matt Powers' regenerative soil course, and there's also his microscopy course.
Did he go this deep on the microscopy?
Yep.
Nice.
Yeah, he's got the same microscope. I bought the scope because of it. I have a little bit different of a camera. Most of the camera that you can get through the soil food web through Matt Powers' course through LW is just the BioVid. So, which the BioVid definitely has its advantages, but since I'm using a DSLR, I can do a little bit more, but at the same time, I'm at a slight disadvantage.
There's always trade-offs.
Just because, like a microscope camera is designed for a microscope. This is designed to be a high-quality photography camera. It was not built to be a microscope camera. But it does work pretty good.
Clearly.
It's a Sony A7C. Gets me... Some things I could do better, and other things the BioVid definitely seems like it can do better. But yeah. Yep, there's a little fungal strand.
Yep.
And then as we dive down, it looks like it goes in.
Yep, the vascular system.
Yeah. But yeah, as far as roots go with that P4S, this is the bright one. And I kind of can tell that's one thing that I like about the DSLR is because instead of I'm sure you can figure out what the ISO that the BioVid is using at any given time. But this one, I could just set it right here. So if I know if I'm at a certain ISO, which is the sensitivity of the sensor, and it's bright enough for me to see it like this, now I can judge, how much phosphorus and nutrients are in that particular root by pretty much how bright it's glowing.
Mm-hmm.
So if I have to go all the way up to 1200 or 1600 ISO to be able to see the root with the epifluorescent light, it's not got much going on. But if I get down to like 400 ISO where we are now and it's this bright, it's like, holy cow,
a lot going on.
There's a lot of stuff in there. There's a lot of stuff to phosphorus. Yeah, and I think it's going to be cool if we could get light to do more than in other wavelengths and other stuff and narrow it down. Because that's the hard thing. It's like it's easiest with phosphorus because it normally phosphorizes. So if you hit it with this particular light and it glows bright green, you can be pretty darn sure it's phosphorus. But then other things that glow orange and are different lights, there's a lot of crossover. So it could be this, could be cobalt, could be magnesium, could be, so it's interesting. I would like to know more about these, the spectroscopy meters that are coming out that are supposed to be able to test nutrient content and whatnot, and what wavelength they're using to narrow down what particular mineral.
Really? When are those coming out?
There's one, forget the one that Matt Powers was just talking about, but he was demoing one and they're working on it. I think they're still a little bit away, but essentially they want to even be an attachment for the phone or a pocket handheld device where you could just shine it on a piece of fruit in the supermarket and it will tell you its nutrient contents.
Oh, there was a guy that did all of that work years ago.
Yeah, and they're still working on it, still getting it better and trying to make it into a handheld, portable product and not a, because nobody's gonna buy a, $10,000 device to go detect their nutrients. But if we can get it to the point where
maybe
it can either be an add-on for the phone, or I think this one was, I think they were gonna start selling it at like $250, $500 or something but.
Yeah, Ken might remember the name of the gentleman that invented it because he did come on this podcast years ago. It's slipping my memory.
Yeah.
But
yeah, that would be awesome.
Yeah, I don't remember his name either.
Oops.
But where else are we on this route? Oh yeah, let me go all the way over this way. Did we look at this part of the route? This is actually the very tip in the end of it. Oh, did I go too far? Gotta go back a little bit. This is popping off the.
There you go.
There we go.
Yeah, that's got to be really sensitive at that level.
Yeah. Oh wow. There is all sorts of squiggly stuff. Squiggly fungi right here in that top part.
Zoom in on the tip of that. Looks like it's clubbing.
Yeah.
Which means it's about to spoil you.
That is definitely a cluster of fungi in there. And everything's so bright. It's even hard to make out. Like sometimes like when you go in to right here, you could really make out all the cells of the plant. Like everything's like all those square lines kind of right in the middle are all going to be the plant cells. Even if I turn down the ISO a little bit more, get a little bit darker, there's not as much glow. But yeah, there's so much going on and so many strands. Like up over here, you can kind of see all the square. Yeah, like normally, yeah, you see all these square pieces, but there's so much other stuff going on in there, which I'm pretty sure is all endophytic fungi that you can't even make out the squares of the plant.
Yeah, it's definitely a healthy root.
Some roots are just like, it's just perfect squares, kind of like right over here. Like we could see a nice, like there's right here at the top, there's two nice rectangles there and kind of a rectangle above it. But
there you go.
Yeah, some more rectangles. Those are just the cell walls of the plant, and the calcium kind of glows orange, slightly green. But yeah. And now we're getting to the point where the tip of the root is curving off the scale, so I got to do a whole lot of adjustment. Oh, but wow. Yeah, look how bright green this bottom is. And there's where the root snapped where I pulled it out. Didn't quite get the full tip.
That's all right.
Yeah. It's tough to do. The roots are, and you'll never really get the full tip.
No, because let's face it,
it's always going to snap. It'll get super fine.
It's going to be wrapped around organic matter. So no matter what you do, you're never going to extract it.
Yeah.
That's why they do wet extractions when they really want to find out. And even the wet extractions aren't 100%. The tip is very fragile.
Yeah. Yeah, but just because all of these are around the plant and whatnot, I think might be some kind of algae. And it looks like there's a septi there. Huh. Yeah, I'm not certain that could definitely be algae. And not microplastic. Just because it's so long. It has some features and doesn't look like tattered. Usually it just looked like, when it's definitely plastic, it looked just like a tattered thread. Yeah. Oh yeah. Well, there's a good look at a root. Yeah, we got any questions?
Yeah, we got a couple
where
questions.
Else to go from here. But.
Yeah. And we can cut out a little early today, which would actually be beneficial. I've had 3 phone calls and 2 texts come in since I got on.
Yeah.
So yeah, why don't we break from this and dive into questions with Ken?
Okay, I was trying to find the name of that gentleman.
Bob.
Yeah, I've brought him on.
I met him at a conference back in forever ago. Dr. Lane was speaking in Worcester, and I lived in Mass. So I wanted to go out and see her. And
Dan Kittredge.
Dan Kittredge, that's the name.
Yep.
Now he kind of handed off the torch to a group of people. I don't know.
Yeah, I think so. I'm pretty sure they are. Or I think they're still going. I think that
No, the company is definitely going. I mean, people are screaming for it.
Yeah.
But he was going through some times, and I don't know whether he just stepped back temporarily or basically handed the torch off. But it might be interesting to try to get him back on again to see where it's at.
Okay, so let's go with our questions. Why don't soil testing companies require a water sample as well? The two go hand in hand, but we don't seem to be testing them together. Just seems weird.
Well, it's a valid point. I mean, I do request water tests from my clients. Sometimes they're apprehensive, or because it's a little bit more expensive than the cheap ones that they can get from the guys that want to sell them water filters. But recently I stumbled onto New Age Ag, and they were really fair. I mean, they were like 70, maybe $80 for the test. So I generally do request it, especially out here in California, because the water quality is just so hard out here. It's New England, you have a much more balanced and often regional differences, but just up and down the East Coast or West Coast out here, I'm seeing it's always just very, very hard and alkaline. But that's a great question. Yeah, it should be part of the standard, because when you're trying to treat the soil chemistry, which is the only limitation to the biology, and then you spray it with a bunch of hard water, it's got chlorine and fluoride and all this other shit in it. It can definitely affect, especially long-term soil health. So great question.
For instance, when we were looking at the test, you mentioned that copper was a little low. I happen to know that I have virtually no copper for some reason in my water. I'm high in iron in my water, but there's basically no copper. So,
yeah, and copper ions are super important at these intercellular interactions and reactions. So you don't want the sulfur that uses a pesticide, or the copper that gets copper sulfite. You want to try to get the mineral, or maybe it is copper sulfate that is the right mineral. I had to find some for a client, except for I don't remember what I did with the information.
No, I was just in the hardware store, and I was walking by trying to find some isopropylene, and I saw a copper fungicide. And I'm like, what the heck is copper fungicide? And I'm like, yeah, well, copper can. I can see it working, but what is it?
Right. So again, you're looking for the pure mineral form that you need to mix with water and soil drenching, so you get it down in the profile.
Okay, well, our next question is: I'd like the epifluorescent option. Is it an attachment?
Yes, it is. It's just a box that goes between the head of the microscope and the top of the microscope, in between the camera and the objectives. I'm not sure how compatible it is with other microscopes, because it's an LW scientific microscope thing, and it's set up to bolt right on. But have to look to see if it was compatible with other microscopes. But I don't see why not. And from what I've seen, the different attachments are pretty basic and pretty standard across different microscopes.
Cool.
And LW Scientific will tell you, if you tell them your microscope and be like, hey, will this fit on it? They'll probably get right back to you and say, hey, yes or no.
And you can always cheap out and get a UV light, black light, and use a regular microscope, but it's never going to be as clear and brilliant as what he's got there.
Yeah, a little bit different wavelength, slightly off. But
And then our final question from Farmer Cheryl: is the turmeric growing in the horizontal layers in the shallow container?
I didn't build it quite as good as I did the big bed, but yes, I did put clay and some pebbles and a little silt from the creek bed, just the freshwater creek bed that goes by. Grabbed a little silt from there. Yep, and I did throw, because I built them at the same time, so I did throw a little extra stone, clay, and whatnot, and then put my soil on top of that.
Nice. Yeah, I've gone down to as small as I think a 6-inch or an 8-inch pot, and it still works great. Again, I prefer having the tray around it, so when I water, I can see if I've overwatered. There's a way for it to come out. So that the tray liner, the top of the tray liner should be quarter to half inch below the top of your E horizon, just so you don't create a mud layer or a swamp between those two layers. Got to get the water to be able to get away from it. But yeah, you can do it. I mean, I wouldn't see why it wouldn't work in a 4-inch pot, right? It's just geology. It's just a system.
Yeah. And also, LW gives a 37% discount to Matt students.
Oh, that's good to know.
To Matt Power students, yeah.
Yeah. Well, don't you have students, Matt? Come on.
No, I wish. I try to teach people. No one wants to listen to me, though.
I know the feeling, my friend. I've been a friggin' guy crying in the desert for fucking 20 years.
I'll put up your website. And also, guys, Matt has a YouTube channel. So if this is something that you guys like to see, follow Matt on YouTube at Shooting the Soil, and you're going to see this kind of content all the time.
Nice. Well, listen, I really want to thank you for being a loyal fan of this channel and coming on repeatedly and giving us a safari, of the microscopy world. It's really fun. I think you've done a good job with, the tools that you've put together, that measure, as well as, getting the fluorescent attachment. It's just, it's fun. It's an adventure. So really appreciated that you take the time to come on here and give us a
Yeah, definitely.
I like it. I have fun.
You're all right. As long as you have fun, that helps. And Ken, as always, thank you, buddy, for all the hard work you do to put this together every week and make sure that it happens. And remind me when I get busy friggin' being a mad scientist in the garage. Oh, Leighton, you're late. Oh, shit. So that was my fault.
It's always fun, guys, when Leighton doesn't show up on time. You're going, what's he doing?
I'm doing this really deep dive on dissolved organic matter, dissolved organic carbon, the combination of both, including nanoclay, is starting to wield into the fold. So I'm doing a lot of extractions to see what the best way to get it out. And then that way I can figure out maybe how to scale it up. Because one of the big things that is missing in a depleted or suffering soil system is just that pure dissolved organic matter, or that dissolved organic carbon, because that really gives all of the biology in the soil the ability to just suck it up and breed or divide. So you really want to build something back fast. You want to give them, a really good steak dinner, with some mashed potatoes and some broccoli.
Like Matt, you had 24% organic material?
Yeah, it was up there.
Yeah,
that's amazing.
Over the last couple of years, getting up there.
Yeah, and a CEC of 10. I mean, that's dynamite.
With the biochar and everything, and every time I look at a little piece of biochar from the soil, if I find one in there, it's like a city compared to everything else. It's like, that's where all the microbes go.
Well, hey, it's a party, man.
Yeah. You guys want to see an image? If you check out the thumbnail for this video, surrounding Matt's image is an image of biochar.
Very cool.
Yeah.
Okay, well, I think we'll end it there, guys. And Leighton, you can go back to being your mad scientist. I'd like to see the Einstein, eyebrows, though.
They only grow when they want to grow. Actually, the problem I have, dude, is they curl down and stick in my eyeballs. Oh, talk about driving you nuts, because you're like, you brush it away and it just snaps right back in again. So I tend to keep them somewhat trimmed when they start sticking me in the eyeball.
Well, Lily is my biggest nemesis for my going that way because she comes with scissors and starts trimming them. Okay, everybody, have a great day, and we will see you on Wednesday with me and Andy Lopez.
Peace out, everybody. Good to see you, Jeff.